All right, so I'm going to keep this short. I'm going to talk about the 5-4 set and the 5-4 go. And really my intention is to keep this short. What is it talking about? In this section, it's talking about segments that are parallel. We have to find corresponding segments, and are they parallel? That's what it's asking. Well, two things we need to define. It's talking about in a pre-image and an image. Well, what is the pre-image and what is the image? Think of a picture, and we talk about a 4x6 picture, and we want to take that picture and we want to enlarge it and make a poster out of it. Which would be the pre-image and which would be the image? Pre being before. So obviously the picture would be the before, the other would be, the poster would be the after. So when we look at that, all right, fine. I want to look at this figure, and if you look at your paper, by the way, this is just some clarification. Here's my paper, here's the 5.4 set. This paragraph right here is talking about the diagram on the right, not the one below it, the diagram on the right. So make that known. If you're looking at this and looking at the diagram below and seeing this on the board and saying he's talking about the wrong thing, no, right? The paragraph on the left is talking about the diagram on the right. Now I have to discuss which is the pre-image and which is the image. Well, the other day when we talked about triangle, let's see, CDE, and we translated that, we labeled the other triangle C prime, D prime, E prime. The reason for the prime notation is it differentiates between E and E. If I got rid of the prime and said point D, you have no idea which D I'm referring to. But now if I say point D, it's up here, point D prime is here. So the before, the after. So that leads me into this. I know that this figure on the left is the pre-image, and I'm going to mark that with P, P-R-E, and the other one is the image. And I'm just going to write image in that. Pretty soon we'll get away from doing that, but at least for now we're going to do that. Now I want to name corresponding parts. We'll start with any one of these 5 points. F. I want to name a corresponding segment, FH, segment FH, is parallel. The whole point of this whole thing is naming parallel segments. It is parallel with F prime, H prime. That's it. Basic. Let's do one more and then I'll tell you how many you need to have. Well, if I went from F to H, I can go from F to J. So segment FJ is parallel to F prime, J prime. Done. Now there should be 5 in total, so you'll have to look at the other 3 and figure out which ones those are. All right? Now I'm going to move on to the rotation. Well, the segment on the left goes with the diagram, or segment on the right goes with the diagram on the left. 2 other things I will make you aware of. The copy cut off J prime and H prime. So make sure that you label those accordingly. J prime and H prime. And I'm going to make sure that I'm over here. All right, you can see it better now. J prime and H prime. Make the H look a little bit better here. All right. Now, if I rotate 180 degrees, well, what's happening with a rotation? Here's what happens in a rotation. This figure here, my triangle, gets rotated about this point M 180 degrees. Where's 180 degrees? Here's 90. Here's 180 degrees. When I rotate 180 degrees, this bottom here, if I rotate it, should be parallel with the top over here. That's what happens in a rotation. So over here, I'm going to be naming segments that are parallel. Well, gee, I had 5 over there. Guess how many I better have over here? 5. Now my diagram on the board doesn't look as well or as good as the one on your paper. So you're going to have to look and study the one on your paper here. I'm going to just start with the pre-image. I'm going to label that pre. Remember, there's no prime. And over here is the image. All right? It has all the prime notation. So pre-image, before, after. So I'm just going to start with F, and I'm going to go to J. So segment FJ is going to be parallel to what? Segment F prime, J prime. Now, I could have said this backwards. I could have come in and I could have said J prime, F prime. It's still the same segment. This segment here, when I rotated it, becomes this segment here. All right, so you'll continue. You have 5 of those to do. I'm not going to give you all those. Reflection. When we move to a reflection, what happens in a reflection? Well, watch what happens in a reflection. When I reflect something, I see the back side of it, right? Here you see the blue, the red, and the black. When I reflect it, I no longer see those. It looks like a translation, sort of, but no, it's here. It looks like it might even be a rotation. No, because in a rotation, I still see the front side. In a reflection, you don't. So in here, again, it's asking us the same thing. Now, I've colored these lines. Again, sorry, got to make sure that I move this over so you can see. I've colored these lines so that you can see the difference and see the corresponding parts. All it's asking is, are the corresponding parts parallel? Is GJ in the pre-image, GJ parallel to G prime, J prime in the image? Well, think about it. Will these ever cross? At some point in time, if I extend these lines infinitely in each direction, at some point in time, right here is where they're going to cross. So the answer to that is no. If I do that with EG, I extend in either direction. And again, just stop and think about it. At some point in time, they're going to cross. If they cross, they're not parallel. You can do that with, and I know your paper's black and white, but you can do that with the blue lines. Extend, extend. They will intercept somewhere over here. Okay? The black segments, even there. So the answer to this one is, how many are parallel? None. And then the last thing I'm going to discuss is triangle congruence. Making a congruent statement and giving a reason why. Number 10. Number 10 is one of the harder questions. You can do 8, 9, and 11 on your own. Well, when we make a congruent statement, it's basically saying one thing is congruent to another. Angle G is congruent to angle J. I can say that because they're congruent, right? The reason for this statement is given information. Not all the time are they going to give me information. Well, what they're after here is one triangle congruent to another. So a triangle congruent statement is simply saying one triangle, and I can start wherever I want. I can start at the left and go to the right, or right and go to the left, and I can start at one of 3 spots. Triangle G, F, H. If I'm going to say that triangle, and I'm going to say it's congruent, I'm going to say a triangle is congruent to another one. Now I started at G, think of where I have to start. I have to start at J. If I went G to F, I need to go J to, M to K. Now, I made this statement. I still need to have a reason why I make that statement. In geometry, when you make statements, you have to have reasons. Like I can say, the sky is green, just lots of different things. But unless I can back that up with a reason, a valid reason why, then the sky's not green. All right? I need to have a valid reason. So our valid reasons are angle, side, or side, side when it comes to triangles. And that's what they're getting at. They're getting us to review what we did the other day. Well, G is an angle, J is an angle. They are corresponding parts. F and M are angles. They are corresponding parts. GF, JM are corresponding parts, and they are sides. So the reason for me being able to make this statement and it being true is angle, side, angle. All right, there you go. Hopefully I got through that. Ask questions if you need to. Make sure you get your assignment in on time.